Good afternoon, Priyu. Good afternoon.
Afternoon,
Good
teacher.
afternoon, Kaupan. Kaupan, right? Your name, Kaupan. Good afternoon.
Teacher, you come from Philippines.
Oh, no, I'm not from Philippines. Do you know Bhutan? Bhutan?
Bhutan.
Yes. I'm from Bhutan. It's a very tiny country. It's between China. You know China, right? The country China. China, big country. China and India, it's in the middle. It's a very small
Bhutan.
country. Yes, Bhutan. Let's wait for your friends, okay? How many students are there in this class? 9? 9 of you? How many students in the class? Priyu, how many students are there in this class, Priyu?
Maybe 26.
26? Wow. Like in the morning, I taught grade 8, section A, and then there was only, section 1, there was only 9 students. Okay, so let's wait for your friends, okay? Yesterday, you went to get your vaccine yesterday, right? Did you get the vaccine? Your first shot or second shot?
Second
Second shot. Okay, okay. How was it?
I got the fever. I
Really?
got fever and I don't know.
You have a pain right here,
Yeah.
right?
Yes, teacher.
Take care, okay? Take care, eat well, and if you have a fever, maybe just take medicine.
I already take medicine,
Okay.
so I'm well now.
Oh, you're fine now, right? You got it yesterday, right? The shot, the injection. Okay. Have to take care, okay? Eat well, then you'll be fine. I only have 4 of you in the class. Let's wait. You can get your book. Do you have your book, everyone? Get your science book and turn to page number 63. Okay, and later on, we will be doing exercises, okay, in class exercises, which is 6.1, exercise 6.1. The first part, the number 1, and number 4. We're going to be solving these 2 questions in the class, okay? So, did you receive? I've sent something in the line, right? Did you receive? Yes, right? Okay. We're going to be solving 2 questions, okay? How long has it been? It's been already 4 minutes and students are not coming. Who was your previous teacher? Who was your previous teacher?
Teacher CK.
Teacher CK. CK. I think teacher CK misses you guys. Let's wait. Let's wait. So I have right now Kaupan, Jomjam, Kaimuk, Pi, P-E-I, Pai. How do I pronounce your name?
Bye bye.
Pai. Oh, Pai.
Yes.
And Priyu, I have Priyu. I have Fuji, right? Fuji. This one is Fuji. I have Fuji. Fuji, are you Japanese, Fuji?
Yes.
Oh, she's Japanese. Oh, the name, it sounds like Japanese, that's why. Let's wait for your friends. What period is it right now? What
Last.
period is it? It's
Uh,
the, yes, it's the
last.
last, second last, right? Is it last for you? There is 9 periods, right? In total, 8 periods. Okay. So right now is the 8th period. We had a long, long day, right? And first, let me introduce myself, right? I forgot to introduce myself. My name is Yishi, okay? Teacher Yishi. I'm gonna be teaching you guys science from now onwards, okay? And everyone, welcome back to second semester, and this is your first science class, right? And some of you, I don't see your faces, Fuji and ABHI, Abibu, right? Abibu, can you please turn on your cameras? I would appreciate if you turn on your cameras. So 1, 2, 3, 7 of you in the class. So let's start, right? Let's not waste time. It's been 7 minutes already. Okay. I'm gonna be sharing my screen. Please let me know if you don't see my screen. Okay. We're going to be starting off with a new chapter, okay? New chapter, which is about work and power, But our main focus for today's topic is just on work, okay? Just on work. So let's look at, do you have your books, others who just joined the class? Can you please get your books? It's page number 63. Fuji and Abby. Abibu. Okay, so we can say the word here, right? The work. Work is defined as the product of the force and the displacement of an object in the direction of the force. So what happens is when we lift an object, right? Let's say if we lift an object, we need our force, right? We need our force. And also with that force, we'll be able to move that object, right? This is called as displacement. Movement of object is called as displacement, okay? When we lift some object, the object has to be moved. That is called as displacement, okay? The force that we put in to move that object, okay? The work is defined as the product of force and displacement of an object in the direction of the force, okay? Now, let's look at the examples, okay? Let's look at the formula of work, okay? So the formula of work is work done, W, you can say this W, right? Equals to force, which is Newton, okay? The force is Newton times, you do into, okay, force times displacement, which is measured in meters, okay? This is the formula of work. Now, let's look at the SI unit of work, okay? The SI unit of work done is Newton meter, okay? Or it is called as joules, okay? Now, let's look at the next one. It's about energy. Energy is ability or power to do work. So let's say if you want to do some work, you need your energy, right? You need your energy to do that work, right? That one is called as energy, okay? And the relation between the work and the energy is when the work is done, right? When the work is done, energy is transformed into another form. So example, I'm going to show you example. For example, walking up the stairs. So in order to walk up the stairs, in order to get to the top, we need to walk up the stairs. In order to walk, we need to have energy, right? We need to have energy and we need to force ourselves to walk up to the stairs, right? This is one of the examples, okay? Walking up stairs. Okay. Another example that I have for you guys is lifting a heavy object. Okay, lifting heavy object. So when you lift a heavy object, do you need energy and force to lift objects up? Kaimuk, do you need energy and force to lift the object up?
Yes.
Yes, we need, right? We need energy and both force and energy to lift the object up. Okay. This is the example, another example, okay, of work. Now, let's look at this one. Work is said to be done only when a force acts on an object and displace it or move it. Okay. So there are two conditions required for work done. Two conditions or two factors for work done. First is the force should act on an object. Okay, the force. Let's say for example, I am playing a volleyball. Okay, for example, I'm playing a volleyball. So the volleyball, right? In order to move the volleyball, in order to play the volleyball, I need energy, right? I need energy, right? I need energy to hit the ball, right? I need energy to hit the ball, right? So this energy, the force, should act on the object, okay? And the object, right? When I hit the object, does the object move? Does the ball move when I hit it on? Jumjam?
Yeah.
Does the ball move when I hit?
Yeah. Yeah.
Yes,
Yes.
it moves, right? It moves, it moves. So these two factors, okay, the force that we act on, we hit on the ball, right? It's the force that we act on the object, and the object moves, right? The object moves is called as the displacement, okay? These two factors should be there, okay? Either of them, right? If one is missing, let's say the force, if there's only force, the force, right? If any of the above condition doesn't exist, then work is not done. Okay, these two should always come together. Okay, if either of one is missing, that means the work is not done. For example, another example that I'm going to be giving you guys is, let us analyze the situation below. Okay, another example is, let's say we push a wall, but does the wall move? When we push the wall, does the wall move? True. When we push the wall, do you think the wall will move or not?
Yes.
The wall will move? How? I try to push the wall. Do you think it will move? Your house wall?
No.
No,
No.
right? It cannot be moved. Okay. So here, what is happening is he's forcing himself to push, but then the object isn't moving, right? The wall isn't moving, right? So here, that means the work is not done. Okay, there is no work done as the wall doesn't move. Okay, everyone, do you understand? Right? Clear? Crystal clear? Okay. These two factors should always include, okay, have to be together. If there's only force, then work is not done. If the object is just moving, that means the work is not done. Has to be together, always be together, okay? Either of them missing, right? Then means the work is not done, okay? So next example, let's see what we have for the next example. Let's analyze the situation below, right? How about this? What do you understand from this? PP, right? PP, pai, sorry. What do you understand, pai from here? From this picture, what is he trying to do?
Hit the ball.
Yes, he is trying to hit the ball with the bat, right? So So what happens? The force is applied, right, by the bed. The force is applied by the Batman, the person, the boy is the Batman, right? He's applying the force on the ball. So what will happen? Will the ball move or will it not move?
The ball moves.
Yes, the ball will move, right? So that means both the force is applied and the displacement is also having, the object is also moving, right? That means the work is done here, okay? Do you understand the difference now? Do you get it, everyone? Okay, I'm gonna ask question, okay? Next one. Let's see. This girl, okay, the lady is a weightlifter. Okay, let's say she is lifting a weight. Okay, she's lifting a weight up, but she isn't moving. Okay, she's just lifting it up like this, but she isn't moving. So, is there work done here? Is there work done here? Fuji? Is there work done here, Fuji? Is there work done here? The lady is lifting a weight up like this, but she isn't moving at all. Her body is not moving. Her body is still, okay? So does that mean there is work done or no work done? How about Jomjam?
Oh.
How about Jomjam? Is there work done or no work done?
No work done.
Very good. No work done. Why do you think, Jomjam? No work done. Why do you think?
Because there's no movement, no motion.
Very good. No movement, no motion, right? She isn't moving. That's why. Okay. Very good, Jomjam. Excellent. Okay. So there is no work done as she isn't moving. She is putting the force to lift it up, right? To lift this thing up, but then she isn't moving. Okay. So there is no work done here. Okay. Now let's go to another example I have for you guys. Carrying a bag and not moving. What do you think is the answer here? Abibu, right? Abibu. What is the answer here, Abibu? What is the answer here? Carrying up this person. You don't know? This person is carrying a bag. Okay, he is carrying a bag, but he isn't moving his body. He's just carrying. Okay, so what do you think it is? Others, what do you think it is? Work done or no work done? Pai, work done or no work done here?
No work done.
Very good. Why? Why is no work done? Why there is no work done here?
No movement.
Yes, he is not moving. He's only using his force to lift the bags up, but he isn't moving, right? Okay, very good, Pai, very good. Okay, now let's analyze the next one. What is this lady doing? Kaimuk, what is this lady doing? What do you see in this picture? What is she doing here?
She's pushing.
She is pushing a shopping trolley or shopping cart, right? So, do you think there is a work done here? Do you think there is a work done here? She is pushing, right? This trolley, is it moving? Will it move when you push it?
Yes.
Yes, it will move. So is it work done or no work done?
It is.
It is very good. It is work done. Okay, work done. This is work done because she is putting her force, right? Force and energy to move the object. And the object will start to act, right? The object will move, start to move. you can see the tires, right? It will roll and move, okay? So here, the answer is work done. Sorry, it's work done, okay? So the answer is work done, okay? Okay, now let's go to next slide. Work factors affecting the work. I have mentioned this before as well, right? There are two factors that are affecting the work, right? The first one is the amount of force that we put in to objects, okay? The amount of force that we put onto objects to lift things up, to push things, right? The second one is the distance, right? When we push things, right? When we push the trolley, the object will start to act, the object will move, right? When the force is applied. This is the second factors affecting, okay? If any of this factor is missing, right? Either there is force applied, but there is no movement, okay? So that means there is no work done. How about the object is moving and there is no force? That means there is no work done as well, right? So both has to include, okay? Both has to be together all the time. The force, there has to be a force. There has to be an object that will move when the force is applied, okay? Okay, everyone understand? This both should always go together. If one is missing, that means the work is not done. Has to be always together to make work done, to make things work. Okay, everyone? Understand? Okay, now let's go to next one. Okay, so we're going to be solving this. Okay, to solve this, right? To solve this, we need a formula. We need a formula, which do you remember the formula, everyone, for this? Okay, let me read the question, okay? A boy pushing a trolley with a horizontal force of 20 newtons. Okay, he's pushing a trolley, right? He's pushing a trolley with the force of how many newton? It's 20 newtons, right? And the trolley, it moves 5 meters horizontally, the straight, okay? So what is the work done? So in order to find that, we need to have the formula. We need to solve this. We need to find a solution. So the solution is, first, let's remember the formula, okay? So the formula for work done is force times displacement is the formula, okay? So the force, how much is the force here? Pi, how much is the force here? How much newton of force here?
20,
Yes?
20 Newton.
Very good, 20 newtons. How about displacement? Jomjam, how about displacement? How many meters did it travel? Or did it move? Jomjam?
Wait. Let me calculate.
Yes?
To 100.
No, it's a 5 meter, okay? 5 meter. 5 meter. Let me show you, okay? So the force here is 20. 20, you can see this here, right? 20 newton. Whereas the displacement is how many? How much he traveled is 5 meter. Only 5 meter. He traveled only 5 meter horizontally straight, right? And the answer is 20 times 5 is how much joules? Do you have your calculators, everyone? How much is 20 times 5? Kaupan, how much is 20 times 5?
Yes.
20 times 5, how much is it?
Yes, sir. Okay. So
Okay,
that's what we get.
okay. Okay, how much is it? Do you have your calculator with you guys? Do you have your calculators? You can calculate 20 times 5. Kaimuk, how much do you think it is?
100.
Yes, very good. 100. Okay, it's The answer is 100 joules here, okay? This is the answer here, 100 joules. Now, let's go to next one. Okay, next question I have for you guys. So let's say, can you see this diagram, right? Can you see this diagram, everyone, on the right-hand side? The person, right? The diagram shows that the boy is climbing upstairs. He's going upstairs, right? The boy, he weighs 40 newtons, 400 newtons, okay? He weighs 400 newtons. So how much does the boy do to climb the upstairs, okay? So in order to find the solution, what is the formula? Fuji, what is the formula of work done? Hello, Fuji. How about Priyu? What is the formula for work done?
Okay. What terms is on a bandai?
Yes, yes. Kaupan, yes.
Yes.
Okay, so the boy, right? He is climbing upstairs, right? But he himself weighs 400 newtons, right? How much work does the boy do to climb upstairs? So the formula here is work done equals to force times displacement. So in order to find that, I will write it down, okay? How much is the Newton here? Priyu, how much is the Newton here, Priyu? Hello, Priyu. How much is the Newton here?
5 times 400.
No. Newton. This one, N. How much? How much is this?
400.
Yes, it's 400 newtons. So you write it here, 400 newtons, okay? 400 newtons, you write it here, the symbol, newtons, right? And times displacement is how much he traveled, the distance he traveled, okay? So the distance he traveled is, as he is going upstairs, right? So here, it's 25 meters. He isn't going straight, right? He's going upstairs. So it's 2.5 meters, not 5 meters. So what you have to do is you have to multiply by 2.5 meters here. Okay, so how much is it now? 400 times 2.5. How much is the answer? Can someone tell me? Do you have your calculators? How much is the answer here? Pai, how much is the answer here? 400. 1,000. Yes, very good. 1,000. And what is the SI unit? What unit do you have to put? Do you remember, Pai? It's no, it's joules.
Joule.
It's joules, okay? It's joules. So the answer is right here. Do you understand, everyone? Okay, now let me give you an example, okay, for work done. So a person is swimming. Okay, for example, a person is swimming, okay. So is there any work done there? A person is swimming in the pool. Is there any work done there? Priyu, is there any work done? Work done or no work done? If person is swimming in the pool, what is the answer, Priyu? Is it work done or no work done? How about Jumjam?
Yes.
Let's say, for example, a person is swimming in the pool, okay? A person is swimming in the pool. So is there work done? Is it work done or no work done? Person swimming in the pool, is it work done or no work done?
Work done.
Yes, very good. Why work done? Why do you think it's work done?
Because the person is swimming, it create the motion movement.
Yes, very good, Jomjam. So he need to force himself to move in the swimming pool, right? To move, to swim, right? Okay, very good, Jomjam. Well done. Okay, so we have now 10 minutes. Okay, 9 minutes, something seconds. So we're going to do exercises. Okay, so do you have your books already? So question number 8, define work. So can you guys give me answer? What is work?
Work is a product of the force
Mhm.
on an object and the displacement of the object in the direction of the force.
Okay, very good, very good. The work is a product of a force on an object and displacement on the object in the direction of the force. Okay, when the force is applied, there's this displacement, right? The object will move. When force is applied, the object will start to move in the direction that we force, right? So this is the definition, okay? Question number B, state the relation between work and energy. Remember, I told you there are two relations. Oh, there's only one relation, sorry. State the relation between work and energy. What is the answer here? Kaimuk, what is the answer here?
When the work is done, energy is transformed into another form.
Yes, very good. When the work is done, right, the energy is transformed into another form, okay? Very good. How about question C? States two factors that affect the work done on an object. Remember, I told you there is two factors that always have to come together. What is the two factor? Do you remember the two factors? How about Prue? Question C. See two factors that affect the work done on an object. What is the answer here? I told you there is two factors here, right? Hello, Prue. No, you don't know the answer? Can someone give me the answer of C? Or maybe I will do it, okay. So the two factors that affect the work done on an object is the amount of force that we use on an object. And another one is the displacement of the object in the direction of the force that we put in, okay. So this is the answer of question C, okay. And the last one, D, what is the SI unit of work? This is very easy. Who wants to answer? SI unit of work.
Joule.
Very good. It's joules. Very good. It's joules. Okay. Are you guys done? Let me know if you're done or not.
Yeah, I'm done.
Done? Okay, very good. Done. If you're done, very good. Kaupan, are you writing, Kaupan?
Teacher ผม pictures ถ่ายรูปครับ photo
You have to write, okay? You have to write it.
yes
Okay. Okay, very good, everyone. Now, let's go to the next one. If you're done, okay? Let's go to the next one. How about this one? Question number 4, okay? Analyze each situation below. Let's read the instruction here. Analyze each situation below and put a tick in the bracket of work done and put a cross in the bracket of no work done. So first question, right? The first sentence is lifting a book from a table. Is there work done here? Pai Pai, is there work done here? Yes or no? Lifting a book from a table.
Yes.
Yes, so you put a tick here, okay? Very good, Pai Pai. So you put a tick here. And how about the second one? Thinking about the way to carry out an experiment. Is this person doing a real experiment? No, right? He isn't doing a real experiment, but he was only thinking in his mind. So is there any work done here? No, right? There is no work done because he isn't putting the force, right? It's just thinking on his head. Sitting on a chair. Kaimu? No, right? Sitting on the chair, no force, right? Okay, very good. No force, no displacement as well. Walking upstairs. What is it? Walking upstairs. Yes, correct, right? Yes, correct. You need to put a tick. You need to, what do you need? You need energy and you need force to walk up to the stairs. You need to move your body, right? To reach upstairs. So there is work done here, okay. E, standing with the back on a shoulder. Standing on the back on the shoulder. What is the answer here? Is there work done? Yes or no? Priyu?
No.
No, very good. Priyu, no work is done as he isn't moving. He's just using his energy to carry the bag on his shoulder, but there is no displacement, no movement, right? So it's false. Okay. So we have 2 minutes remaining. And assignments, you can send it in the line group, okay? The assignments, you can send it in the line group. I think we need to set an album, right? So in the next class, we will be doing another, okay? We will be focusing on powers and we will be learning how to solve. We already learned, but looks like we don't have time to do that, right? So question 5 and question 7, we're gonna be doing this in the next class, okay? So that's it, everyone. With this, we have come to an end of our class, okay? I'm going to stop sharing the screen because I think you're done with this, right? It's just writing a tick and cross, right? Okay, so with this, we are done with our first class. So it was nice having you guys, okay? And I will see you next Thursday, okay? I have only one class with you guys, right? So I will see you next Friday. Until then, take care and be safe, okay? Bye-bye.
Thank you,
Bye,
teacher.
welcome.
Yes,
Okay, welcome everyone.